You're live.
All right, so seems like we are live. So, good evening, everyone. Welcome back to yet another fun and exciting session, the last, but of course not the least, of our World Space Week celebrations. Now, I'm sure that all of you must have enjoyed your World Space Week celebrations, where we, did a lot of fun and exciting activities, especially the escape room yesterday itself. So, if you don't know what I'm talking about, just visit our YouTube channel, visit our Spacetopia website, and you will get a clear idea and you will get to experience very exciting activities for yourself, where you learn about space science and astronomy with a touch of fun and activity based STEM, process that we use. Well, now coming to today, some of you might be aware that the theme for the World Space Week this time is living in space. Now, since whatever we are doing, we're around the settlement in space, let's today dive deeper into how we can actually think about settling in space. Just imagine when you just build a house, let's say, on our earth, you take into consideration so many different things, right? You take into consideration how is the soil, how is the land, whether it will be able to sustain the earthquakes, tsunamis, and all these things, isn't it? Similarly, it's very important that you take into consideration the very important facts when you think about settling in space. One of the biggest challenges that scientists have been facing since decades is to protect ourselves against the harmful radiation which is lurking around in the entire space, be it in the moon, be it on the Mars or any other foreign planet. There's so much amount of radiation. How about people who are live with me? You give your responses in the chat that what kind of harmful radiations are actually present in space that can, pose a danger when we think about settling over there. And to protect from them, scientists have started developing various different technologies. Scientists have thought about various different experiments and approaches, but one of them is a very innovative approach which is quite common but at the same time very uncommon, and that is the use of ice in space settlements. So you will be amazed to know that how ice can actually play such an important role in protecting us against the radiations that are lurking around in the space. Okay, so, what we are going to do today is that we are going to perform an experiment. So, we will perform an experiment to understand how we can actually use one of the finest properties of ice, and we will understand that how scientists are planning to use that property in settling in space. That means in creating settlements in foreign planets. So before we proceed, let me just quickly show you the materials. Now I'm sure that people who were continuously tuned to us, you have an idea that what were the materials required for today's experiment. But if you don't, you can just have a look at the different items that are required, basically 2 to 3 small ice cubes, a white string or thread, table salt, that is the normal salt that we all consume every day, and a glass which is filled with water. Okay, it has to be filled with water till the top. Again, no cold water, hot water, nothing, just normal water. But make sure that the ice cubes which you have, do not take out those from your freezer as of now, just keep them. Take them out. I will give you a couple of minutes at that time. Before starting the experiments, just take those ice cubes out and you will be ready for that. All right, let's now dive deeper into this and understand that how ice is actually important. If you look at some of the past missions, that is to hunt for water ice, then it includes the Lunar Reconnaissance Orbiter from NASA. In 2009, it actually mapped out various regions on the moon which could potentially contain ice. Then came Chandrayaan 1 from our own home space research organization, that is ISRO. And in 2009, our Chandrayaan 1 confirmed the presence of water, especially towards the polar regions of the moon. And of course, that was followed by Chandrayaan 2 and Chandrayaan 3, wherein ISRO further discovered and advanced our understanding of how the ice is actually distributed all across the surface of the moon. Similarly, if you look at expeditions to Mars, it also includes various missions that have eventually aimed to study the distribution of ice and distribution of water across the surface. For example, you have the Mars Odyssey in 2001, you have the Mars Reconnaissance Orbiter in 2006. You also have the Phoenix Mars lander, which was the first lander to actually land on the surface of the this planet, this red planet, and it gave us very detailed information about the distribution of ice across the surface. And of course, our own ISRO also conducted a very flagship mission, Mangalyaan, which was actually the code name for Mars Orbiter Mission, or MOM, in 2013. It was a grand success, and we did it in a very small amount of budget. And also, very importantly, it gave us very astonishing clues about the presence of water ice, especially towards the polar regions of the Mars. So what did we find after spending so many millions of dollars and so many decades of research? Well, we found water ice on Moon, and we confirmed the presence of this ice, especially in the permanently shadowed craters where there is hardly any sunlight that is able to reach. And that is the reason that the water has remained in ice form, in cold form, across centuries, across thousands and millions of years. And especially, it can the we have estimated that the water ice reaches about 5 to 10% of the mass in some locations. And we also found water ice on Mars, where we discovered that water ice is present towards the polar regions and also towards the mid latitude regions. So the question comes, is that what are we going to do with this water? We are searching for so much amount of water, and I'm sure that logically many of you might think we need water to drink, we need water to survive, isn't it? But how about people who are right now online with me? You can respond to me in the chat that what are the other uses of water? How else can we use the water? So I have the chat section along with me. So how about somebody actually tells me that apart from drinking, is there any other use, or drinking or household purpose, is there any use that this water can actually come upon when we think of settling in space? Now, if you look at this water, then whenever we extract the water, what we need to do is that we need to actually purify it. We need to actually convert it into a form so that it is usable, isn't it? So there have been many technologies that space agencies have been working upon. One of them, which has actually reached its experimental stage, is the lunar ice purification system developed by the UK Space Agency. So if you look at this process, then it's actually pretty simple, because once we extract the water ice, what will do is that we'll melt it. And when we melt it, we'll get liquid water, but it's still unsafe for drinking because it contains the moon's soil and various other dust particles. And that is why we will actually subject that liquid water to filtration through a very special kind of membrane. And once the filtration is done, the regolith, or the moon's soil, will be removed. People who are not aware of the word regolith, for them, regolith is actually the soil of the moon. How about somebody tells me that if regolith is the word which we use for soil on other planets as well? So let's say if I have Mars soil, if I have soil on any other planet, will I use the term regolith or some other word? Let me know in the chat section. Once the regolith is removed from the water, it is subjected to a process called distillation, which is a process where the water is evaporated and again condensed. And that removes the heavy metals which are present that might be harmful for our body. And when it is subject to final purification stages, it will ultimately yield safe, pure water that can be used for drinking, but very importantly, that can be used for production of hydrogen and oxygen as well. So a couple of you have actually answered me in the chat that the water can be used for washing as well as for having a bath. And while that is correct, but apart from those household usage, there are very important scientific uses that this water actually has. First of all, drinking, which involves, of course, all the household, the components, for example, bathing or washing clothes. But apart from that, very importantly, it can also be used for production of hydrogen and oxygen by a process which is called the electrolysis of water. So electrolysis is the process where electric current is actually used to separate the water molecule into hydrogen and oxygen as per the equation that you can see on your screen right now. And the hydrogen which is produced can actually be used to form rocket fuel. That means the fuel that the rockets will use, the space shuttles will use to travel between Earth and that moon or whatever planet we are settling in. While the oxygen can act as a propellant for the rocket fuel, and at the same time, it will also help us to breathe, right? Because apart from water, we need the oxygen as well, right? In fact, we first require the oxygen to breathe, and then comes water in requirement. So that's how the water actually plays a very important role, not only for drinking, having a bath, or washing clothes, or household purposes, but also for acting as a rocket fuel, and also for generating oxygen that we can eventually breathe. Apart from that, the water can also play a very important role that we were actually discussing in the beginning. That is playing a role in radiation protection. That means water ice actually contains hydrogen atoms, isn't it? I'm sure that all of you are aware about hydrogen atoms. These hydrogen atoms play a very important role in absorbing and deflecting the harmful radiations that are actually present. Some of you had actually answered me that gamma rays, cosmic rays, are the very harmful radiations, and that is absolutely correct. Gamma rays, cosmic rays, X rays, and many other harmful radiations do not reach our Earth. So, how about you tell me in the chat that what is the reason or which layer of Earth actually protects us from these harmful radiation? Because on Earth we do not have any particular device for that purpose. Our atmosphere itself has a layer. How about you tell me in the chat that what is that layer protecting us from the harmful radiations? If you look at ice, then ice can actually reduce the radiation exposure by up to 50%. In fact, latest research even shows that it can, multiple layers of ice can further reduce the radiation levels up to 90%, and that will make the long-term space settlement very feasible and very economical for us. And this is the reason that scientists across the decades are spending millions of dollars, are spending so much amount of time, money to actually find water either in the form of liquid, either in the form of vapor or in the form of ice, so that we can use this water for various important purposes. So I believe that now you know that how water can actually be useful apart from drinking. But you may think that protecting from radiation, it can be done with the help of ice only. How about I build a base in a something called as a lunar cave? So these are caves which are naturally present within the craters of the moon where we can actually build the base. If I am building something inside a crater in the underground, then of course my base is already protected from harmful radiation, isn't it? Similarly, there is something called lava tubes, tunnel-like structures in which once lava used to flow millions of years ago, but now it has cooled down, it has dried up, so no more lava, just vacant tunnels, which are called lava tubes. And we can even build our bases inside the lava tubes. So naturally, we are getting protected from the harmful radiation. So that is why these act as natural shielding. But there is something also called active shielding. In fact, some of you have actually answered to me that ozone layer is the layer which is present in the atmosphere protecting us. While that is partly correct, ozone layer specifically has a layer called the magnetosphere or the magnetic field layer. Okay, it is made up of ions, also called ionosphere, and that actually protects us from all these harmful radiations. You can see how these blue lines that you can see in the pictures actually depict the way in which these radiations get deflected. And due to the interference between the magnetic field of our Earth and the harmful cosmic rays or the solar radiation, there's a very special and very beautiful phenomenon that occurs in the polar regions, especially in the northern countries. Very beautiful colorful structures that get formed in the sky. How about you tell me in the chat section what is the name of that colorful or that color or that beautiful phenomenon that occurs when these solar radiation interacts with the magnetic field layer of our Earth? And I will see that who is able to give me the correct answer. But you can just guess that how difficult it will be to build a base below the surface or build a base where we have some mechanism to generate magnetic field as big as the planet or as big as the moon. That's not practically very feasible or economical, right? That is why we came up with certain passive radiation shielding strategies where we develop materials on our Earth and we carry them. Those are called ex-situ materials because we carry them from the Earth itself. For example, we have polyethylene, which is a hydrogen-rich polymer that can effectively absorb those radiation. Similarly, you can see Kevlar. In the pictures, the orange portions, you can see they are made up of polyethylene and they are covering certain instruments so that they are protected from the harmful layer, from the harmful radiations. Similarly, Kevlar, which is often used to form bulletproof vests as well. Okay, that's where you might have seen. So multiple layers of Kevlar actually can protect us from harmful radiation. But the biggest limitation is it is very expensive to transport those materials. In fact, many of those materials are actually used to protect certain equipment and instrument in the International Space Station, which I believe that some of you might have an idea what is. You can tell me in the chat what is the International Space Station or the ISS in short. So due to their limitation of being not economical, we focus on the in situ materials. That means we try to source the materials that are already present. Now, what exactly is present already on Moon or Mars? Well, we already have the soil, that is the regolith. And remember, I had asked you that can anybody tell me that what is the term given for the surface or the soil on planets, on other planets, or places other than the moon? Well, the term regolith itself is used. Okay, so regolith shielding is a way in which we use the surface itself to protect our habitat. But again, it's not always possible for us to build all the habitats below the surface. It's also very expensive, and again, we won't have any ventilation or view. So that is where our water ice shielding comes into play, where we will use the ice itself, which is present in the moon, which is present in the Mars. We'll excavate the ice, we will purify it as we learned earlier, and we'll use it to our purpose itself. So you might imagine that how are we actually going to use ice for shielding? Well, ice shielding is a very innovative approach that the space agencies have recently developed. And here they aim to create multiple layered shields of ice which can adapt to the radiations. Radiations are not constant. Sometimes it is more, sometimes it is less, sometimes it's gamma, cosmic, X-ray, whatever. So we can actually manipulate the ice layers and we can adapt our habitat to protect us from that particular radiation. And I can see that some of you have actually answered me aurora borealis, and that is absolutely correct. Auroras is the phenomenon that occurs when the magnetic field of our earth interacts with the harmful cosmic rays. It protects us and in turn shows us those beautiful phenomenon called auroras. Well, we're talking about manipulation of ice. Manipulation means altering, right? Can we really alter the melting point of ice? Because scientists are thinking of altering or playing with the melting point of ice. If they are able to alter the melting point, they think that they will be able to control the radiation which is coming towards our habitat. Well, let's perform an experiment to actually understand if we can alter the melting point of ice, or if we do so, how we can do so. That experiment is nothing but the ice cube rope experiment. And the picture might have given you a clue that what we are going to do. So it's time now for you to gather around your materials. Just quickly get 2 to 3 small ice cubes, a white string which is about 15 to 20 centimeter long. If it's a thicker string, it's fine. If it's a thin string, I suggest take 2 or 3 strings together and just combine them. Then you can have table salt, some 2 spoons of salt, that will be more than enough, and a glass which is filled with water, normal water, up to the brim. Till the top, just fill the glass with water. Okay, and just wait for a minute so that you all can gather the materials. And I strongly suggest that you perform this experiment on a very stable surface. Do not try to perform it on a table, or if you are performing it on a table, then try to use a very big table which doesn't move, because you need a very stable surface. Your experimental setup must not move at all while we are performing the experiment, and I will tell you why later. Just ensure that you are doing it on the floor, let's say, if possible. You can do it on the kitchen slab, or you can do it at any flat, stable surface. Okay. So if anybody has actually, arranged the materials, you can just give me a thumbs up, or you can give me a yes in the chat box so that I know that you have actually arranged the materials. Well, just imagine that when you are performing such kind of experiment, what is the result? Because just now you saw the picture where there was an ice cube which was being held with the help of a string. So how about you just keep guessing? By the time people are actually arranging the materials, you just keep guessing that what will be the actual result. Will you be able to actually pick up the block of ice with the help of a string without touching it? Well, we'll find out. Okay, so let's proceed and let's understand that how we are actually going to perform the experiment. So I have a video here for you where I have performed the experiment, and I'm going to show that to you stepwise. So as you can see, the first step is to arrange your materials in the way in which we have actually placed it. You can see that I have a plate which contains the ice cubes. I have a bowl which contains table salt, and I have a glass which is filled with water. You can fill it up to the brim, okay, up to the top. Once you have filled it, what you need to do is you need to place a block of ice in the water itself. Okay, so just make sure that when you are placing the block of ice, you are using a block which has a at least one flat surface. That is very important, because if it doesn't have any flat surface, it will be difficult for you to perform the experiment. So just make sure that it actually has a flat surface, at least one flat surface, and you are actually very gently putting it inside your glass of water. Okay. Now, once you have put this inside the glass of water, just a second, I will just play the video for you. What you need to do is you need to take your thread, you need to take the string, and you need to very carefully place it over this ice which you have actually put. So you can see how very carefully I'm just putting it. Do not stretch it too much, just put it carefully so that your string actually remains suspended over the glass which contains your water and the ice cube. And make sure that maximum portion of your string is in contact with your ice cube. That is the most important point in this experiment. Just make sure that the maximum portion of your thread is in contact with one of the surfaces of the ice cube. Otherwise, if it's not the case, you can just move the ice cube a bit with your finger, and you can make sure that it's stable and it has maximum area of the thread which is in contact with it. Once you have done that, what you need to do is that you need to now start putting salt over the thread itself. So just make sure that you are putting sufficient amount of salt. Even if you put excess salt, there is no problem, but don't put less. Put excess amount of salt so that your entire thread and ice gets covered with the salt. Okay, your entire portion of the thread that is in contact with the ice gets enveloped by the salt. And once you have added this salt, just wait at this step for 2 to 3 minutes. Do not disturb the apparatus at all. And while putting the salt, make sure that you are not disturbing the apparatus at all. Your table should not move, or your slab should not, there should be no disturbance. Just leave it there for 2 to 3 minutes. So in the meantime, while we are waiting for 2 to 3 minutes, how about you tell me in the chat that what will be the result? Will you actually be able to, pull the ice block with the help of your string or with the help of your thread? And also, just let me know in the chat that how much amount of salt are you actually putting? 1 pinch, 2 pinch, 3 pinch, or whatever. Because some amount of salt may actually go below and it may get dissolved in the water, but that doesn't matter. Just make sure that you're putting enough amount of salt. Okay. So people who have done, you can just reply to me on the chat that you have actually completed this particular step. Because once we are done with this, your experimental part is done. And then the next part will be just to observe the magic that happens over here. So I believe that most of you are actually able to do. I can see that there were some votes as well in favor of the fact that all of you have actually arranged the materials. Well, let me just take you further. While you are waiting, you do not need to hurry along with me. While you are waiting, just observe. Even if you wait for more than 3 minutes is fine. Do not wait too much, otherwise your ice will melt down. Okay, but wait for some 2 to 3 minutes, 3.5 minutes maximum. That will be all. Okay. So are you ready to see the magic that happens when the salt eventually dissolves, and what happens to the thread? Let's find out. Well, here's the video that shows my observation. So as you can see, what I am doing is that I am just holding the two ends of the string, and very carefully and gently I am just raising it up. And as you can see, voila, we are actually pulling up the cube of ice out of the water. How magical is that? Just with the help of a thin thread, a thin string, we are able to pull that ice block out of the water, and I'll just keep it aside. And you can repeat the same for other ice blocks if you have many more ice blocks. Okay, so that's what will happen when you wait for 2 to 3 minutes. Okay, so that's the magic that happens. And why does that happen? That is the biggest question. How did that actually happen? What did that salt actually do? Okay, well, if you look at the result, then what you exactly saw? You saw that when you are adding salt, you're waiting for some time. There is some kind of chemistry that is going on, due to which the thread actually gets stuck on the surface of the ice. And when it gets stuck on the surface of the ice, you are able to eventually pull it above, and you're able to pull it out of the glass tumbler. So why it works? Because salt has a property of lowering the melting point of ice. You know what salt does? Salt changes the melting point of ice. It lowers it. So how about somebody tells me that what is the melting point of ice in the chat box itself, so that I know that you are aware that what is the melting point of ice. Only then you will be able to understand the science behind the experiment that you just did. As salt dissolves, what it does is that the ice initially melts, of course, due to the room temperature and due to the temperature of the water itself. But it eventually freezes. Why it refreezes? Because you have added salt, you have now reduced the melting point. So now it starts freezing again. When it refreezes, what happens is that it takes the thread, the portion of the thread that is in contact along with it, and freezes itself within its surface. So, that is the reason why your thread gets stuck to the surface of the ice. And when you eventually gently pick it up, you're able to pick up the ice cube and you're able to do that magic. So, any magic is actually science. Once you understand it, it's no more magic, it's actually science, isn't it? I will have a pro tip for people who are actually performing the experiment. If you have been able to successfully perform, then it's great. If you have not been able to successfully perform, you can use a thicker string or you can use multiple strands. That is why in the beginning I had told you, if you have a thin thread, you can actually take multiple threads, some 3 to 4, and you can merge them together so that you are able to pull it properly. Because sometimes the thread might be thin, so it might get torn off. More surface in contact with the ice, the stronger the bond will actually be. So this concept is actually called freezing point depression. This particular concept is a concept where the sodium and the chloride ions. I'm sure that all of you are aware about salt. It is actually sodium chloride. People who are not aware or kids who do not know, don't worry. As you go to your higher classes, you will learn about that. But sodium and chloride are the ions which are present and together form table salt. Once you add the salt to the ice, it interferes with the ability of the water molecules to form ice crystals. So it eventually reduces the melting point of ice. And some of you have actually answered to me. The correct answer is 0 degrees Celsius. So since pure water freezes at 0 degrees Celsius, when you are adding ice, it is no more pure. When you are adding salt water, it's no more pure. There's some kind of impurity, and increase in impurity will decrease the melting point. It reduces its melting point to -9 or -10 degrees Celsius, depending upon how much salt you have put. And that is the reason that why that thread actually gets stuck to the surface of the ice. And this process is technically called regulation. Regulation is the concept which scientists are now planning to use. Now just imagine that, do we use this principle actually on our planet Earth? Because before going to space, let's see that if we actually use this. Well, we do. Even in fact, in the colder countries, for example, in Russia, in the northern European countries, and in Canada, if you see very frequently, 4 to 5 times each day, there is salt that is often, spread on the roads. This is done to prevent icing on the roads and pavements, so that the people and the roads, they are able to very smoothly walk on the road itself. They are very able to very smoothly, very safely walk on the pavements. Similarly, salt is even used in ice cream production. You might have observed that when you keep the ice cream even in freezer, it doesn't develop the ice very easily. Even at -4, -5 degrees Celsius, your ice cream remains soft. That is the reason why it remains soft, because salt has been added in appropriate concentration. Some of you must have traveled in flights. When you travel in flight, you go to a height of about 9 to 10 kilometers above the that 33-35,000 feet. That is about 9 to 10 kilometers above the Earth's surface. Do you know the temperature at that particular height? How about you tell me in the chat section that what is the temperature which you face when the plane actually goes to that particular height at 35 or 38,000 feet above the ground? Over there, it's very cold. Okay, and due to that cold temperature, ice may get developed, but special kind of salt solutions are coated on the surface so that ice does not develop. And of course, some of you must have actually heard or seen your mother in the house using salt to actually preserve different food items, especially fruits. Why does she do so? So that ice does not develop on it, because if ice develops, it will eventually get spoiled. So this is how the ice actually helps us. This principle of regulation actually helps us in various things, in various day-to-day activities in our own Earth. So that is why scientists actually thought of taking up the same principle for building a base on Moon and Mars. And that's where NASA came up with the Ice Home concept. In collaboration with these companies, that is Search Plus and Clouds Architecture, what they have done is that they have developed this ice home. This is a conceptual picture of how it will actually look like. I'm sure that you might be aware of igloos, right? these dome-shaped structures that often are formed in the colder countries, especially in the very frigid zones in polar regions. People form igloos so that they can protect themselves from the cold temperatures and from the cold winds that blow over there, because it remains warm inside. The concept is different, but the imagination is similar, to form igloo kind of structure with the help of multiple layers of ice. Because due to the property of ice of getting manipulated by adding salt, by adding some kind of impurity, what scientists are going to do, they are going to engineer multiple layers of ice, and they are going to form the wall of this base. And this wall of base can be manipulated because every layer will have a different melting point. You can actually manipulate, okay, using different salt solutions, using different impurities. You can actually manipulate the temperature, the temperature of each layer, and eventually the melting point of each layer. And that is why this freezing point depression, or the regulation principle, it becomes very important, so that we can even think about settling in moon or Mars or any other planet later. If you look at the concept that they have built, they have thought that more radiation will come from the top side. So that is why what they will do is that they will form thicker walls. That means more layered walls over there. But since there will be less radiation from from the sides, they will form thinner ice walls, each layer again with a different melting point. And since each layer has a different melting point, you can manipulate each layer so that you're able to control the entire wall of your ice home, and you're able to protect yourself from all these harmful radiations. So I believe that that gives you a vivid idea of why we are actually looking out for ice, we are looking out for water on moon, on Mars, on all the different planets that we are trying to explore. This is the reason, not only for drinking, not only for washing or bathing, but also for hydrogen, which can act as a rocket fuel, for oxygen, which we'll use to breathe, and for forming materials that can help us, that can protect us from these harmful radiations which are lurking all over the space. So, with that, I would like to conclude the session today. I would like to conclude the celebrations of the World Space Week 2025. I believe that all of you now have a clear idea of how you can also use the freezing point depression principle to do a fun experiment and activity in your home. If you have not been able to perform the experiment, I suggest you watch this video again, you watch the procedure properly so that you can perform it. And you can click a picture, you can shoot a video, and you can post it on the social media. You can follow us on our Spacetopia, social media channels and handles, and you can tag us as well, so that we know that you have actually successfully performed the experiment. Well, with that, I thank you all so much for joining today, and we hope to see you in the next one. Good night and bye bye.